Dear friends, in this problem we are going to discuss about GATE 2021 ECE question. This topic comes under control system and the topic is block diagram reduction technique. In this problem they are given a block diagram and asking the transfer function y of s by x of s. If you try to solve this problem using block diagram reduction technique, then it is a tedious process because you should know the block diagram reduction rules. So I can easily do this problem with the help of signal flow graph. For that I need to convert this block diagram into a signal flow graph by assigning nodes to the relevant points. Input points, summer, the branch point, this summer and this output point. Each of the 5 points is given a node. Node 1, node 2, node 3, node 4, node 5. Now I can easily write the signal flow graph. Node 1, node 2, node 3, node 4, node 5. 1, 2, 3, 4, 5. From 1 to 2 you don't have any gain terms, so I can simply write 1. From 2 to 3 you have G1 as a gain term, so I can use G1 here. From 3 to 4 also you don't have any terms, I can use 1. From 4 to 5 also you don't have any gain terms, so I can use 1 here. Now from 2 to 4 you have a gain term G2. 2 to 4 you have a gain term G2, but the meeting point is plus terminal, so you can simply use G2 here. From 3 to 2 you have H, but the meeting point is minus. The meeting point is minus, so you should use minus H. You should use minus H, not simply H, because the reaching point is minus of the summer. Okay, now you can use Mason's gain formula. Mason's gain formula to find the transfer function. The transfer function is equal to summation del k pk by delta, where k is number of forward paths. Okay, now you should know P1, P2, because you have only 2 forward paths. What is forward path? From input to output, how many paths are there? Input to output you have 1 path, and the next path will be the straight way. Okay, so k equal to, you have only 2 forward paths. First forward path will be this straight way, so on the way you have 1 G1, 1 G1. If you multiply the 4 terms you will simply get G1. For P2 you should consider the second forward path. In the second forward path you have only 1 term, that is G2. All the other terms are 1. You don't have any other forward path which starts from node 1 to node 5, because this path the arrow mark is reverse, so you cannot go this path. You have only 2 paths as a forward path. Now I am going to find the individual loops. What is individual loops? Individual loops are starting from a node and ends with the same node. If you consider this one, it starts from the node 2 and goes here, reaches 3, again it comes to 2. So this is the individual loop. I can draw the individual loop here. 2, 3, this is minus H, this is G1, this is node number 3. Now individual loops is given a notation L. First individual loop is equal to, just multiply all the gains, G1 minus H. If you multiply you will get minus G1H. This is the one and only individual loops in this signal flow graph. You don't have any individual loop which starts from a node and terminates at the same node. Okay, now we are going to find delta. This delta. The formula for delta is 1 minus sum of individual loop gains plus sum of gain product of non-touching loops. Two combination of non-touching loops minus dot dot dot. Here you don't have any non-touching loops here, because if you have two loops then there is a possibility of non-touching loops, but we have only one loop, so there will not be any non-touching loops. Now you can substitute the individual loops, sum of individual loop gains, but you have only one individual loops. So next step will be delta equal to 1 minus sum of individual loop means minus G1H1. Minus G1H1 you don't have any non-touching loops, so you will get 0. Delta equal to 1 plus G1H1. G1H. Okay. Now you need del K. Del K means you need del 1 P1, because the value of K equal to 2. So del 1 and del 2. Del 1 and del 2. Del 1 is equal to delta of part of the graph which non-touches first forward path. So you should find delta for the graph which non-touches the first forward path. Okay, I can see the first forward path here. I don't have any part which non-touches the first forward path, because all the parts are touching this forward path, this straight line. All the parts are touching, all the graphs are touching, or you can say all the loops are touching. So you don't have any part which non-touches the first forward path. So you can use the same formula, but 1 minus, there will not be any individual loops, there will not be any non-touching loops, etc. So you will get 1. Similarly, delta 2 means delta which non-touches the second forward path. You can see the diagram. This second forward path also touches all the paths, there will not be any loops which non-touches the second forward path. You can easily see here, this is the second forward path. This loop is also touching, this small loop is also touching in this place. So you don't have any forward paths. So you can write 1 minus 0 plus 0, etc. You will get 1. Delta 1, delta 2, both are 1, because you don't have any part of this graph which non-touches either first forward path or second forward path. All the paths are touching. Now I can substitute in the Mason's gain formula. T of S is equal to summation del K Pk by delta, that is del 1 P1 plus del 2 P2 by delta, since number of forward path is equal to 2. Now you can substitute delta 1 is 1, P1 is, where is P1? P1 is G1. plus delta 2 is also 1, P2 is G2. The whole divided by delta means we already found delta. Delta is 1 plus G1H. 1 plus G1H. You will get G1 plus G2 divided by 1 plus G1H will be the final answer. That is the transfer function. So the choice is G1, G2. Yes, choice A. Thank you.